For today we have to do 7-4, but before that, what kind of questions do you guys have for me?
69 for my homework.
Which one did you want to go over on the quiz, Walter? Walter, which one did you want to do on the quiz?
How about 3?
The inverse tangent of the tangent of 3 pi over 4? So from quiz 7, which was the one you just turned in, number 3, asks you what tan inverse of tangent of 3 pi over 4 equal. This one you can actually do, you should actually do without, just evaluating it, right? Like you know, for example, what the tangent of 3 pi over 4 is. Right? Because you can go on your unit circle, and you can say, okay, 3 pi over 4 is over here. 3 pi over 4 is in the second quadrant. It has an x and a y value of root 2 over 2, root 2 over 2 with a negative. So what's the tangent at 3 pi over 4?
Negative 1.
Negative 1. So when you plug in 3 pi over 4 to tangent, you get out negative 1. So this becomes negative 1, which means I now have to evaluate tangent inverse of negative 1. But remember, whenever you're doing an inverse function, you have to remember the range. You have to remember where the inverse functions are allowed to spit out angles. So what kind of angles can I get out of tangent inverse?
Negative pi over 2.
Right, so here's negative pi over 2. Here's pi over 2. Tangent inverse can only give me angles this way, right in here. So what I have to figure out is where on my unit circle in this region can I get out another negative 1 tangent value. Right, it equals negative 1 here, but there's another place in the fourth quadrant where tangent equals negative 1. So down here where you split this quadrant in half, you're going to have root 2 over 2, root 2 over 2 with a negative. So tangent's going to be negative 1 here as well. What angle is this? So it's either 7 pi over 4 or negative pi over 4. They both land you at the same place. But which one do you need for tangent inverse? Negative pi over 4, because if you try to go 7 pi over 4, you're going to pass these barriers here. Right, so 7 pi over 4 is outside of your tangent inverse range. It's too big. So instead you have to go backward like this. So this should be negative pi over 4.
What about 2? Is it?
Sine inverse of negative 1 is negative pi over 2.
So it can't be 3 pi over 2? Because
Well, again, it's going to pass the barrier. Okay. You wanted number 69 from what section? 7-3?
7-3.
So is there any way you could read it to me?
Yeah, it's tan theta equals 2 sin theta.
Tan theta equals 2 sine theta? Oh, yeah, I remember this one. I think we started this one before, but now we should finish it. Or maybe not. Maybe we didn't actually. Maybe this one's different. But, okay, so we have two different trig functions here. Tangent of theta and 2 sine theta. By the way, did the instructions say solve on 0 to 2 pi or find all solutions? Or
0 to 2 pi.
0 to 2 pi. Okay. So we want to find our solutions between 0 and 2 pi. Okay, so what I would do is try to change these all to the same trig function, and I would start with tangent. What can I do with tangent?
Sine over
cosine. Tangent is forever and always sine over cosine. So I can apply an identity that says instead of writing tangent theta, I can write sine theta over cos theta. Okay, so that's legit. No one's gonna dispute that. This was called the quotient identity. Then what should I do?
Multiply sign or subtract the 2 sign?
Let's
I mean cosine?
cosine. Yeah, I want to get rid of this denominator. I don't like this denominator. Okay, so I'm going to multiply cosine on both sides so that I get rid of my denominator. Multiplying both sides by cosine allows me to cross this out, and it gives me sine theta equals 2 sine theta cos theta. Then what?
Subtract sign.
You want to subtract and get one side equal to 0. Right? I can't do any other identities. I don't know any identity to put in for cosine. I'm never going to be able to get sine into cosine or cosine into sine. But I can get one side to 0 and try to factor. That's my other choice when I have this other type of equation, when I have two types of trig functions. So I'd like to subtract the sine over and then factor if I can. So minus sine theta minus sine theta. Now on this side, sine theta minus sine theta, that's 0. We have nothing left. Now, on this side, don't be fooled. Okay, 2 sine cos and just sine are not like terms. They don't collect. They're not the same in any way. Okay. So when I bring these down, I'm just going to write 2 sine theta cos theta minus sine theta. I can't collect anything. But at this point I can factor. Right, if 0 equals 2 sine theta cos theta minus sine theta, how can I factor this? Take a sign out. There's a sign in both of them. Sine theta. This is your greatest common factor. So you factor this by pulling a sine theta out front, and then you write what you have left. If you take a sine theta out of 2 sine cos, you just have 2 cos theta left. You take a sine theta out of sine theta, what do you have left? So then each of these, now that you have it factored, each of these factors can be set to 0. Either sine theta equals 0, or 2 cos theta minus 1 equals 0. This one I have the trig function isolated, so I can go ahead and go to my unit circle. If sine theta equals 0, I look on my unit circle where my y value is 0. It's either here or here. Right, 1, 0 or negative 1, 0. So what are my angles for sine theta equals 0?
0 and pi.
0 and pi. How come I don't include 2 pi? Well, actually, I don't know what the instructions really say, but if they say something like this, then 2 pi is not allowed as one of your answers because it's too big. So I would do theta equals 0 and pi from this solution, and then I would have to take 2 cos theta minus 1 equals 0 and solve for cos theta. So add the 1 over. Divide by 2, turn to your unit circle, whereas cosine 1/2, it's going to be in the first and fourth quadrant. So cosine is going to be 1/2 up here and down here. So what are those angles?
Pi over 3 and
Yep.
7.
Pi over 37. Pi over
It's hard to do it in your head when it's that
5
pi
pi.
long.
Because it's almost 6 pi over 3, right? 6 pi over 3 would be 2 pi. So my two other answers are pi over 3 and 5. Sometimes times when you have denominators in your equation, you have to, well, I mean, anytime you have a denominator in your equation, you should technically check and make sure that neither of your solutions or that none of your solutions make the denominator 0. Right, if I happen to get a theta that made cosine 0, my entire equation would become undefined and I'd have to cancel it out as a solution. But cosine is 1 at both of these, or 1 and negative 1, and cosine is 1/2 here, so I don't run into that problem. But I couldn't have theta equals pi over 2 for an answer. You guys see that? Why can't I have theta equals pi over 2 for an answer to this equation? What's cosine at pi over 2? Right, if I happen to do all my work and I end up with this answer, I didn't, but say I did, I'd have to cross it out. Because if you plug pi over 2 into cosine, cosine is going to be 0 when theta is pi over 2. So up in your original equation, you have sine over 0, which is undefined. Okay, so if you get an answer that makes your original equation undefined, you have to cross it out. It's extraneous. It doesn't happen all that often. So you're aware. But that's what I was saying. Over here at 0 and pi, cosine is not. Cosine's fine, right? It's 1 and negative 1. So this denominator doesn't have any trouble. I'll erase this before you get too confused. If that confused you, pretend I didn't say anything.
How do you know that you can't just divide by sign in that second line over there?
So whenever you got to be careful when you divide both sides of an equation by a variable. Right? If you have something like x equals 2x, and you divide both sides by x, you get 1 equals 2, which has no solution. Right? But in the original equation, if you put 0 in for x, 0 does equal 0. So there is a solution. So the whole kind of problem is whenever you divide by a variable, you're leaving out a solution. Right? So in this case, as soon as I write divided by x, I'm saying x cannot equal 0 because you can't write it unless this is true. So this is actually excluding one of the solutions. Same thing would happen here. If I divide both sides by sine, I would be saying that sine theta can't be 0. But actually, that's one of my solutions. So there's two ways to handle that. Either never divide by a variable. Never divide by anything that has a variable in it. That's one way. Or, if you do divide by a variable, right, if you decide to go up to this point, and you decide to say, okay, well, sine theta equals 2 sine theta cos theta. And you say, all right, well, I want to divide by sine theta. That's okay, but as soon as you do that, you have to consider the possibility that sine theta could equal 0. So you would have to have sort of a separate part of your equation where you solve this. Now, if you cancel here, you get 1 equals 2 cos theta, which is right here. So as long as you keep track of where sine equals 0, you can divide by it, but that's kind of tricky because you'll forget to get this extra solution. So whenever you divide by a variable, you're missing one of the solutions. So either don't divide or put it in manually.